A lot of the work we did earlier this term on factorization is really going to be important today. So just note that there are many ways of determining the turning point of a parabola. So if we've got this particular function here, y equals x squared take 2x, let's work out the x-intercepts. Right, so we're going to note that x-intercepts occur when y is equal to 0. 0 equals x squared take 2x. Now what I'm going to do here is just address a really common mistake that's made by students. So with linear functions, pretty much when you solve for x, you're taught to inverse op. Okay, so this is the mistake that many students make. What they do is they go, all right, I'm going to add 2x to both sides. And now what I'm going to do is divide this side by x and divide this side by x. And that says that x is equal to 2. Now that's one, or certainly one x-intercept of the parabola down here. What happened to the other one? It's the origin. Well, there's a real danger in mathematics when you just divide through by x, because when you divide through by x, you assume that, so just note this, girls, assume that x is not 0, because you're not allowed to divide by 0. Okay, that mathematically doesn't make any sense. So what you're assuming when you do this move here is that you assuming that x can't be equal to 0. Now the problem is, have a look at what the other x-intercept is. Okay, it's at 0, 0. So you've done something that you shouldn't have done there to solve that way, and that's why it's chopped out a solution. Here's a method I want you to use when you do this problem. 0 equals x, x take 2. What I want you to do is factorize, okay? So once you've factorized or taken out the common factor, we can apply the null factor law. X is equal to 0 and x is equal to 2. And there's both our solutions, okay? So be very wary of doing this. Right, so the turning point. So can you think of a way to determine the turning point? Well, I'm going to address two methods, method 1 and method 2. Okay, I'm not a huge fan of completing the square, but I don't know, let's just do it and see what happens. So I'm going to go y equals x squared, take 2x, halve it, square it, add it, and subtract it. Now there's no constant on the end, or there's a plus 0, so that's all we're going to do. So it's y equals x take 1 all squared take 1. So I'm going to suggest that the turning point is at positive 1, negative 1. Right, method 2. Well, actually, by symmetry, we know that the turning point must be in the middle of the two x-intercepts. So that turning point there must be along the line, somewhere along the line, x equals 1. So what we're going to do is, if this is our original function, let's go y equals x squared take 2x and find y when x is equal to 1. So y is equal to 1 squared, which is 1, take 2 times 1, which is 2. Y is equal to negative 1. So note that when x is equal to 1, y is equal to negative 1. And that's the turning point as well. So another method, and I think I've gone through this before, that's method 2 by the way, I think I've gone through this before with you, is that what you can do is complete the square to get the turning point, or you can average the x-intercepts to get the axis of symmetry, and you can use the axis of symmetry to find the y value, which will be the y value of the turning point. Let's try what we'd call, a full sketch. So we've got y equals x squared takes 6x plus 5 as our function. Let's note that we've got a y-intercept of 5. Okay, so that's important. Now, how do I know that? Because it's that constant there, because when x is equal to 0, these chop out, leaving y equals 5. All right, so we've got our y-intercept. Let's attempt factorize. No, maybe let's get the turning point first. Okay, so what we'll do is grab the turning point. Actually, should I get the x-intercept first? Let's do this differently. I'm going to grab the x-intercept. So what I'm going to do is attempt to factorize. So 5 and 1, x and x, and negative 5, and negative 1. So x take 1, x take 5. Okay, so 0 equals x take 1, x take 5. We're just setting up the null factor law. So I'm going to let y equal 0 to get the x-intercepts. X is equal to 1 or x is equal to 5. Let's pop them in. So there's 1 and there's 5. All right, so what I'm presuming here is that the turning point is going to be like it's, so the function is going to come down like that, turn here, and then come back up again. So the turning point is going to be on the midpoint of the x-intercepts. Looks like it's 3. How would I do that? Let's just check. I do 5 plus 1 on 2. I average the x-intercepts, which is equal to 3. Okay, so what we want to do is test out this when x is equal to 3. Okay, so we want to find out y when x is equal to 3, y is equal to. Now, I can substitute 3 into this. But remember, this is also this. And this looks easier to substitute in because if I put it into here, it'll be 3 take away 1, which is 2, times 3 take away 5, which is negative 2, and y equals negative 4. Again, there's so many different ways to do quadratics that, the real difficulty sometimes with me as a teacher is, that there's just a plethora of ways what to show you, what to do. So this is why I'm trying to do this one a little bit differently. I could have completed the square first to get the turning point and then got the x-intercepts afterwards by factorizing, but chose to do it differently. So notice that I've been able to successfully do this problem here without even completing the square at all. Right, so that's there. So by symmetry, that y-intercept will be there, I believe. Yeah, that's it. Well, let's do our best to draw a good-looking parabola. Oh, that's terrible. Better. A bit wobbly there. Didn't go through the turning point there. All right, let's label all key features. So we've got 3, negative 4, which is the turning point. We've got a x-intercept 1, 5, y-intercept when x is equal to 0, y is 5. Right, so that's a full sketch there. Okay, and so what you're going to do now in class and for homework is to complete many problems, many graphs based on this technique or a technique here. And often girls, we're going to suggest to you that we want a sketch of a particular quadratic function. The way you choose to do that sketch is completely up to you. If you want to avoid completing the square and do it this way, that's fine. If you want to complete the square, i.e. method 1 to get the turning point, etc., that's completely fine. There's just so many different ways to work with quadratics, and it's your job to experiment a little bit. What's faster, what's slower, what's easier, what numbers work for you, etc., etc., and then make your decisions based on that.